Good morning, everybody. Enjoying the conference so far? Say yes, don't say no, because that would be depressing. So, yes, cool. We're going to spend the next hour talking about window functions in DAX. Everybody here uses Power BI and DAX. Say yes again, because saying no would be depressing for the second time. Before we start, just a couple of words about me. I'm Alberto Ferrari. I work with Marco Russo at SQLBI.com. We do a lot of stuff related to analysis services, Power BI, and DAX. I would say that my superpower is definitely DAX and all what is related to the language. With that said, thanks to the sponsor. Remember, despite the fact that you pay to come in at these sessions, it wouldn't be possible without sponsors. So spend just a few minutes of your life, go there, check what they have to offer, because sponsors are a crucial part of any conference. So go to them, say thank you, just because they make it possible to have learning experience and sharing experiences like this. With that said, let's talk about window functions. Window functions are, well, they were new. They are no longer a new feature, even though it's one of the latest features that was introduced in DAX. They are quite a strange type of functions because you can start using them quite easily. And they have features which are useful to compute ranking, to compute moving averages, to compute window functions, to check what is the previous order of a customer, to do a lot of operations that were possible already before window function hit the market. They are much faster than the equivalent code written in regular DAX. If you think about checking for each customer the value of its current order and compare it with the previous order, it's an expression that you can write in DAX, but it's not easy. And not only it's not easy, it's also going to be very slow because you need to use filter, you need to use complex functions. Whereas with the window function, you obtain the same goal in a very simple way and very fast way. So using them is not really hard. Where they become really hard is in understanding exactly how they work. Because they work like magic. You will have the feeling that, yeah, I understand how they work, but then as soon as we write code that is no longer easy, everything becomes cloudy. And we will need to introduce apply semantics. Apply semantics is a unique feature of window function. The idea of apply semantics is that the analysis services team decided to create apply semantics and test it with window functions. If users like it and if it becomes a feature that everybody loves, then it might be the case that apply semantics starts to appear also in other functionalities in DAX. If not, then apply semantics will just slowly die and remain in window functions. So understanding it is useful because it provides hints in what happens really under the hood. Last detail is that window functions are not very commonly used because they are not easy. It's kind of complicated to use them in your everyday DAX code, but they are the foundation of visual calculation. Anybody here uses visual calculations? Raise your hand, say move your head, do something so I get a feeling. Okay, just a few people. That is totally expected. Visual calculation were, as an idea, a beautiful feature. Actually, their scope is quite limited, even though when you need them, they're actually useful. With that said, I'm going to use the slides, but I will probably spend most of the time writing DAX code in DAX Studio because it is easier to see the result and play with code and see what happens. The first window function that we are going to look at is index. What does index do? Index returns the nth element in a table. So if you start with a table like this one that contains brands and sales that we create by using add columns to all the product brands, we create a new column containing the sales amount, and that generates this table. Now, try to figure out without the window functions, would you be able to write a piece of DAX code that returns the first element? If you were to do that, which function would you use? Top n. You use top n1 and you get the first element. Top n works by applying a sort order to a table. So when you use top n, you say, oh, I'm interested in the first 3 elements, 4 elements, 5 elements. And that requires specifying an order by. You do the same with window function. It's just a bit easier, even though for the first element it's the same. You use index 1 out of brands and sales, the table that you create, and then with order by you specify how you want to sort the table. So you want to sort by sales descending, meaning that the largest amount is the first one, you want the first one, and you obtain AdventureWorks, exactly as you would expect. Let's write some code. I need a bit more space and a larger font. Can you read out that size? From the bottom, just say yes or no, so I have an idea. So we create a table, brands and sales, and then we obtain the first element. Now, if instead of returning results, we return brand and sales, just to have an idea of the result, you see that the table by itself, when it is returned by DAX, is not sorted. That is one of the, not problems, but features of DAX. No table is sorted, no result is sorted. Window functions are the only functions that actually use sorted tables. So out of this table, we want the first element by sales amount, so we use order by sales descending, and the result, as you might expect, is AdventureWorks, that is the first element. If you were to obtain the very same result with top N, you would write code like this. You create the table exactly as we did, and then you use a top N 1 out of brand and sales descending. The result is the very same, there are no differences. It becomes more interesting when you want to retrieve the second element, because retrieving the first one is pretty easy with top N. What if I'm interested in the second one? How would you obtain, using top N or using any other function, the second element out of a table? I'm looking at the people who say top N before, because maybe you have a better idea. How would you find the second element of a table? One thing that I forgot to mention is that getting older, I'm not entirely deaf, but kind of. So you need to speak very loud if you want me to hear anything. You do a top N first to get the first two elements, then you reverse the sort order, and then you use top N again to get the first one. And that's exactly what we have here in the slides. Well, index 1, 4, minus 1, this is boring. You can write top N to get the first element, but if you want the second element, you need to do some DAX acrobatics, like return the top N first out of top N 2 out of brand and sales. The first time you sort descending, the second time you sort ascending, and you obtain this way a piece of the second element out of a table. So you can obtain the result with top N, but it's complicated and not worth. Whereas if you were to do that with index, it's much easier. You just say, oh, I want the second element. I need to return result, of course. And here you go. You get a Contoso, which is the second element out of your table. Index, as any other window function, uses an order that starts from 1. It doesn't start from 0. So 1, 2, 3, 4 if you sort ascending. If you use negative numbers, you start from the bottom. So if you use minus 1 descending, you obtain the last element. Tailspin toys is the last element. Do I have the table here in the slides? Tailspin toys, you see, is the last element, the smallest one. And if you use index minus 1, you obtain that value. So index and top N are very similar. And you can express most of index calculation using a couple of top N. There is an important difference that has always been an issue with top N, that is how they handle ties. Top N does not guarantee you that you will find only one row. You say, I want the top N first out of a table, and then you cross your fingers, because it might be the case that you get one row. You might have 3, 4, 5 rows, depending on how many ties are there. If instead of computing the source table using all and then just sales amount, you round the sales amount to the nearest millions, then you see that we have AdventureWorks with 3 millions, but then Contoso, the phone company, and Whiteword Importers all have 2 millions. So if you only sort them by sales, these are ties. And if you express a piece of code using top N, you will get all the rows. Let's check that with the code. We have top n here. No, the other top n. This returns only one row, contoso. I need to keep this source table available. Okay, the second row, contoso. But the thing is, if instead of using just a sales amount, we round sales amount, so we use an m round of sales amount to the nearest million, then the result of brand and sales contains a lot of duplicates. With 2 millions, we have Contoso, Whiteward Importers, and some other, the phone company. 3 millions is the first one with AdventureWorks. What happens if I return top n? I obtain Contoso, Whiteward Importers, and the phone company. So I get 3 rows out of the table. That is kind of annoying because it means that you are never sure that you will actually find one row only. Index is a bit smarter than that. If you compute the source table the same way as we did, computing sales and then m round of sales amount, but then you obtain the second element, index returns only one row. I don't want this evaluate. Only Contoso 2 millions. And it's interesting to understand how come that it did it, because the table by itself contains duplicates. So there are no ways to distinguish between the second row, the third row, and the fourth row. One feature of window functions is that they try to guarantee uniqueness of the rows, adding columns by chance, using their own algorithm, in order to guarantee uniqueness. So the thing is, I use index 2 out of brand and sales and I sort it by sales amount. And index says, that's cool, but if I only use sales amount, the result will contain multiple values, so I will end up returning multiple rows. So even though you just say that you want to sort by sales descending, I'm going to add the brand as another column to the sort order, even though you didn't ask for it, in order to make sure that I sort by sales descending and by brand ascending. If brand is not enough, because I still have duplicates, it continues adding columns in a predictable way until all the rows are unique. The algorithm that decides how many columns to add and how to add columns is deterministic, meaning that it is always the same result, but it's not documented. So we have no idea how to specify which of the 3 rows will be chosen. In this case, it will likely choose Contoso because it uses the brand ascending, but there's no guarantee about that. But it is deterministic. If you want uniqueness, you can add multiple conditions. You can say order by sales descending and then brand ascending, and in this way you specify the full list of columns that need to be used for the sort order, and you end up having control over the algorithm. If the code you write cannot create unique rows, then you get an error. In this case, if brand and sales, instead of containing all the product brands, so the brands and the sales amount, we use select columns to get rid of the brand. So the resulting table, brands and sales, contains just the sales column. And because it contains the sales column, there's no way you can get rid of duplicates. And if you cannot get rid of duplicates, the net result is that you get an error. I think we have the code, there's no need to write it. We use select columns to get rid of the product brand from the table. So brands and sales now contains only the sales amount, and you see we have only sales amount. And if I try to use evaluate index 1, what I get is an error. Index relation parameter may have duplicated rows. By the way, this is one of the most stupid things that the analysis services team decided to do. When you see index relation parameter, you should translate relation to a table, because a relation is the mathematical way to describe a table, because a row in a table actually states a relationship between the values of the column. So relation means table, and when you read index relation, you need to read it as index table, because that's what they really mean. But I say it might have duplicate rows. This is not allowed, so I'm sorry, I'm not going to return any result. Then window functions also gives you the option of using partition by. Partition by means that the table is first partitioned using a column and then sorted in a different way. It's actually sorted by category and sales, then split into category and sales, and the result will contain multiple rows. This time we create a table, brands and sales by category, that contains all the categories and brand. So we have the category, we have the brand, then we add the sales amount, we have category, brand, and sales amount, and then we return index 1, so we only want the first element out of brands and sales, ordering by category, ordering by sales amount, and partitioning by category. What is, in your idea, the expected result of this function? 1 row, 4 rows, because we have 4 categories: audio, cameras, cell phones, and computers. Likely we have some more at the bottom that we don't see because they didn't fit in the screen. So we get 4 rows instead of just 1, because for each category we get the first element. And if we run the code, just to make sure, now we need a bit more space. No. Here it is, brands and sales by category. We first evaluate the table and then we get the result. You see that the table contains categories, computers, home appliances, TV and video, and the result contains only 1 row per category with the brand and the sales amount. Again, can you express the same piece of code using regular DAX? You can, even though it's not easy at all. If you try to think about that out of your mind right now, how many of you would be able to write a piece of DAX code that obtained the same result without index and without these functions? Don't be shy. You can also say, I have an idea. You have an idea. How would you do that? Well, an idea, because I want to start by category, is to get all the values of the categories. For each category, you use generate, which is one of the functions that nobody uses in DAX. I personally love it, but nobody likes that function. So you generate for each category the list of the brands, and out of the list of the brands, you use a top n to retrieve the first element. It's one of the exercises that I do in the master in DAX, and it's very nice, but takes around half an hour to write the code. So it takes a lot of time to obtain a result that index retrieves in a very simple way. And beside, the important thing that we need to learn right now is that index does not guarantee to return only 1 row. And that is valid not only for index, but any window function is not necessarily returning 1 row. Index returns the first element, but it might return a table containing multiple elements, depending on how you specify the details. So all these functions are table functions, and you typically use the result as an argument to calculate, to iterate, or to do further calculations. You can omit the source table. To me, this is the first step towards masochism, because it makes everything more complicated, but you can do that. For example, we start writing code that is a bit more complex. You use summarized columns, and we group by brand and year. We compute the sales amount. That's easy. Just compute the sales amount. But then we want the sales in the first year. So the result will contain Contoso 2017, the sales amount, and then I want the sales of the first year to be repeated for all the rows in Contoso. Then you use calculate sales amount, and then I want the first year. How do you obtain the first year? You use index 1 order by date year. What do I mean by order by date year? What is the source table? All these window functions need to have a table first, and then they get the first, the second, the third element out of this source table. What happens if you omit it? You say, oh, I want the first ordering by date year. Does the source table contain the brand, or the year, or the sales, or brand, year, and sales, or nothing at all? By default, if you do not specify anything, the engine uses all selected of the order by columns. So in this case, because we didn't specify anything, it will say order by date year, and instead of this missing table argument, we should have all selected date year. So the source table contains all the columns that you use for the order by. The idea is that the code is easy to read, but at the same time, at least in my opinion, it's not that intuitive. But the result is neat. You see the brand, the year, the sales amount, and the sales in the first year. Before we move further, oh no, so far we don't need apply semantics so far. So you use order by date year. You could have obtained the same result using all selected date year. This just makes it more evident what the source table is and what is the order by that you want to use. You run the code, you obtain the very same result, Contoso 2017, the sales amount, and the sales in the first year. Of course, you can use this column to compute other calculations. As we said already, if you use a negative index, you want the sales on the last year, you just use index -1, order date year, or you use order by date year descending rather than ascending, and you obtain the very same result. So it's not very common to use -1 because you can simply change ascending and descending and you obtain the same result. Again, can you express the same code using regular DAX? You can. Is it going to be easy? Not at all. It's not going to be a simple query to write. And because now you can also use summarized columns inside measures, this is convenient to create temporary tables inside your measures and create complex calculations that use the result of indexes. Index returns absolute values. So the idea of index is that it returns the first, the second, the third element. And they are quite simple to understand. Offset does not return an absolute index, it returns a relative index. And this requires understanding a bit more how the engine is going to produce results. Look at this query. I'm using summarized column and I'm grouping by brand, year, compute the sales amount, and I want the sales in the previous year. Before, it was the sales in the first year, now just the previous year, so it's a year relative to the current one. And I use offset rather than index. Offset -1 means the previous row, so start from the current one, go to the previous one. And I have a table containing a datum, 2017, the sales amount, and sales in the previous year returns the sales in the previous year, so it's always the previous row. The thing is, previous regarding what? So when I say I want the previous year, previous compared to what? What is the current year? In this case, because the table that I create contains the brand, the year, then the sales amount, but basically contains the brand and the year, when the current year is 2018, I expect that the previous year will be 2017. Make sense? But it's interesting and it's a kind of cloudy, at least it was cloudy for me at the beginning, understanding, okay, but previous compared to what? To what I will find in the filter context, to what I will find in the row context. What happens in the filter context are multiple years. What happens if I'm not grouping by year at all? Can I write this code? How does the engine knows what the current row is? And understanding this idea of the current row is what makes window functions complicated. Because in a simple example like this one, everything is kind of simple. You read it and you say the previous year compared to 2018, it will be 2017. That's fine. But what happens if I get rid of the year? And I compute a summarized column by brand, I compute the sales amount, and I want the value of the sales amount for the previous year. Now that's no longer so easy. At least I look at that and I say, I get a number. The sales will be 2.2 millions and now it's 2 millions. What's the meaning of these 2 millions? What is the value there? I have no idea how the engine computed this number. And that is the problem. So the problem is, how does the engine know what the current row is if there is no year which is selected? In order to answer this question, so what on earth is the current row, we need to introduce the idea of apply semantics. The engine uses quite a complex algorithm to obtain a result and show the result there. Before we introduce and describe applied semantics, one word of warning is the following. Do you really need to learn all the details of applied semantics? It depends. If you really love to understand how the engine is going to answer your queries, the answer is yes. It's fun, it's interesting, it's a technique that can be used. In your everyday job, you will never write a measure like this because it doesn't have a real meaning. You have no idea what the result will be, so why on earth would you ever write that? Make sense? So, it's interesting to learn, it's not really important. But we need to answer what are these numbers. The applied semantics controls the current row. Our goal is understanding what is the meaning of current row in a window function. And it does it by looking at the current evaluation context, both the row context and the filter context, against the source table. The source table is the table that window function use in order to produce the result. And once it finds candidates, it defines a set of current rows, which are then scanned, iterated, and produce their final result. The details requires a bit of study. And because we want to study and understand it really well, we are going to use a query, or we want to produce a result that puts applied semantics really to the limits. I want to build a table like this that contains the order number, the order date, the current order, which is the value of the order, and then the previous order. What do I mean by previous order? I want the previous order by customer name. So I know that this guy, Kenneth Wilson, placed this order and then placed another order. Whereas this other guy, Silke Probst, don't ask me how he chose the name, created 3 orders with 3 different values. And the number that I want to see for the previous order is the previous order of the same customer. It would be simple if I added the customer name to the report, because I use the order by. I partition by customer name, I order by order, I sort it by order number, and I obtain the result. But because I want to make this complicated, because I want to understand applied semantics, I want to obtain the same result without Kenneth Wilson being there. Make sense? How does the engine do it? Well, the first step is creating the source table, and that is kind of simple. I use add columns, summarize sales by order number and order date, and I compute the current order, which is the sales amount. This condition includes 3 customers because I use the customer name and I have a customer that has 2 different keys, so that's just a technical detail. But the source table that I obtain contains the order number, the order date, and the current order. And I order it by order number. Next, I want to add the previous order. And the previous order is this piece of code, offset -1 out of a table that contains the summarized sales by customer name and order number. I order it by sales order number, and I partition by customer name. Now, the reason I think understanding this code is important, as I said, is not because this code is elegant or interesting, but because it's really hard to understand what's the meaning of this code and how it works. The outer summarize contains the order number and the order date and the sales amount. And then I compute the previous order, partitioning by customer name, and customer name does not appear anywhere here. Ordering by order number, it appears there, summarizing customer name and order number. So this offset, all this gigantic part, basically returns the previous order by customer name, even though the customer name is not there. How does the engine solve all this puzzle? It starts from the source table that contains order number and order date. And it executes this code, offset -1 out of a table that contains the name and the order number, this source table, order by order number, partition by customer name. So this is the source table of my offset function. This is the table that I use as the result. And the engine needs to match these 2 tables. So starting from here, it needs to define what is the current row here. Am I losing you already? Just say yes, no, or no. You're still with me. That's cool. So this is the table, the resulting table. This is the source table. Let's say that you are on this row. No, let's go on this row. What is the current row there? How would you match this table with that table? How do you know, first of all? Why Kenneth Wilson? Why the two rows with Kenneth Wilson make some sense to you? Kenneth Wilson is nowhere here. If you match for the order number, this value, you say, oh, I have the order number in the filter context. What can I do with this piece of information? I use the filter context and I use it to filter the source table, saying anything that does not match the filter context I'm not interested in. So I will use this value, 331200, to filter the source table, and that returns one row only, Kenneth Wilson. Once I have this row, because the match is between 331 and 331 here, I know this is the current row, because I was able to find in the filter context something that make it possible to define what the current row is. Once I know the current row, I know that the table needs to be sorted by order number, partitioned by customer name. The previous row is this one, and I find it. Make sense? So what is Applied Semantic doing? It is trying to match the current evaluation context, row context or filter context, with the source table in order to find the current row. And in this case, it can do that because we have a match. I used a different number, but that doesn't matter. It uses this value to search in the source table, and it finds only one row, so it's happy. Things can be more complicated than this, because if I use a piece of code like this one, I summarize columns by customer continent. I filter only 2 years just to reduce the result. I compute the sales amount, and I want the sales in the previous year. If you remember, this is the first example we have seen. Then we moved to the example with the customers and the order, but actually this is the code that we wanted to solve. In this case, things are a bit more complicated because I compute the sales amount and I go to the previous year, ordering by year and partitioning by continent. So this summarize returns all the continents and years. I order it by year and partition by continent, so I want the sales in the previous year for the same continent. But there's no information. Here I have the continent and the year. No, I have the continent, I have no year, and I want the previous year. And there is no year that I can use for the matching. So the filter context of summarized columns contains only 2018 and 2019. And that is the starting filter context. The result contains some value, and we need to understand what is this value. How does the engine produces this result? And Applied Semantics does all this job. Under the filter context 2018-18, for Europe, there will be multiple rows in the source table. Let's get rid of this stuff. Okay, this is where I want you to go. The source table contains the continent and the year, all continent and all years. The filter context contains 2018 and 2019, and Europe coming from the current row. So the engine matches Europe with Europe. And this time it will not find only one row, it will find multiple rows. Then it matches 2018 and 2019 with the current row, and that finds two possible current rows, Europe 2018 and Europe 2019. Should I start from the beginning again? No? Okay. So what happens right now is that there is not one row, there are multiple current rows. And the engine says, under the current filter context, part of which is coming from the current row, part of which is coming from the filter, there are multiple rows in the source table. What does Applied Semantic do? It says, That's fine. Now that I identified the candidates for the current row, I iterate over each of them. For each of them, I compute the previous row, and then I produce the result by unioning all those results. So it says the filter context filters 2018 and 2019. Europe filters Europe. These are the two candidates for the current row. I find the previous row for Europe 2018, and that produces Europe 2017. The previous row for 2019, and that produces 2018. The two results are union together, and that produces the final result, that is Europe in 2017 and Europe in 2018. So the result contains two rows which are the previous rows. This idea of applied semantics is to make it possible to apply these type of functions to any table regardless of what is the content of the filter context and the row context. Is it useful? I don't know. Meaning that it always produces a good result. But if you have in your filter context the values that let you identify the current row, everything is still intuitive. And at the end, we are humans. We need to read our code and understand what the result is. Applied semantics make it possible to obtain a result even in the case where the result is totally not intuitive. Do you want to use it or not? I'm not here to judge, so it's up to you to make your choice. Just be scared, because if you start to like applied semantics and write on the web that, hey, applied semantics is the greatest feature in DAX, they will start pushing applied semantics in all the other functions in DAX. And I honestly don't think this is going to be a bright idea. It's a very nice test, and it's good that it stays where it is. Nobody uses it, nobody likes it, and it's just a feature that is there. So the result of this complicated query, when you look at here, sales in the previous year, this value is the sales amount of 2017 and 2018, because it matched the filter coming from the filter context plus the filter coming from the current row in the source table containing continent and year to retrieve two rows containing the previous year. As I said, it's very interesting, at least to me, from an academic point of view. It's totally useless if you think about using it in the real world. But it is useful to compute complex calculation, like simple calculation. For example, if you want the sales, if you want to create a table that contains different brands, the sales amount and the sales of the previous brand, again, this can be computed in DAX, but it's complicated, whereas obtaining the same code is pretty simple. Let's look at that with DAX Studio. I moved farther, so I need to find where we are right now. Yep.
We do have a question, not about the offset, but about the index.
Okay.
The question is index better performing than the top end when we are looking for the second, top second?
Okay, if so the question is if index is faster or not compared to top n for the first or for the second. For the first element, no, they are basically the same. There's no differences. For the second element, yes, because top n requires two different operations. I mean, the first top n is not complicated because that returns two rows, and the second top n only returns one row. So it's not that speed is bad. But index is very well optimized. So generally speaking, whenever you want to do any calculation that requires navigating through a sorted table, then window functions are the best option, because they are really, really well optimized. And they are designed specifically to obtain this goal. A running total, you can express that with DAX, regular DAX. You can express it with the window function. If you express a running total with regular DAX, the complexity is quadratic, meaning that depending on if you have a given number of rows, the time that it requires to compute the value is the number of rows squared. So it grows very quickly. With window function, the complexity is linear. Depending on how many rows you have, if you double the number of rows, you do not multiply by 4, but only by 2. So they are way, way faster than any other calculation, because they are designed for that. They have been designed specifically to navigate through sorted table and produce their result. If you just think about this, if you need to write this code using regular DAX, this is not going to be simple at all. I create a table, brands and sales, that contains for each brand the sales amount. And then I want the sales amount of the previous brand. So I sort brand and sales by sales amount, and I go to the previous one. Obtaining the same result with the regular window function is not easy at all, because you need to use a top n to reduce the number of rows to anything that does not include myself, and then I get a top n from there. It's going to take a lot of time. The thing is, let's run this code. And I don't see, okay. I have sales amount of wildwood importers, and then 1.7 million, 1.9 million, 2.2 million. So please take a look at the code. I place a filter to all the product brands that have a sales amount greater than 1 million. So I have holes. I'm not finding the previous brand. I'm finding the previous brand out of the current one, because I use all selected product brand. So this filter is filtering only the brands which are selected, and I retrieve the value of the previous brand. Again, obtaining the very same result using top n, it's not going to be easy. It's going to be rather complicated. Window function gives you the option of obtaining these results in quite a simple way. Not to say that they are always useful, but I use them quite often in measures. When you have a measure and you want to compute some set of rows and then perform calculation on top of that, it's easy. Think about writing a chart that shows, or just giving an indicator, are the sales of this customer growing over time or not? So is this customer getting better or not? If you try to do the same to obtain such a result with a regular function, it's not easy, because you need to scan sales, retrieve the order numbers, then you cannot sort them in any way, so finding the previous one is going to be hard. Whereas if you use a window function, you partition by customer, you sort by order number, you get the current value, the previous value, you compare the two, and you obtain the result in a very simple way. The last function, not the last, but one of the last functions we're going to look at is window. Window is by nature a function that returns a lot of rows. It's not expected to return only one row, and it somewhat mixes index and offset, because you specify the coordinates of the window you want to obtain out of the source table by saying I want, in this case, the 60 elements relative to the current row up to 0 elements relative to the current row. So this is going to compute a moving average, because it starts from a day and it sorts by date. So it sorts everything by date, and it computes the sales amount, the average out of this set of dates of the sales amount. So you are on a given date, that is the current row. The engine will find it in the filter context, and it says, oh, I go back 60 days back given to the current day up to 0 days back to the current day. I sort it by date and I compute the sales amount. Again, can you compute such a moving average using regular DAX functions? Of course you can, there's no problem. But it's going to be much more complicated. Whereas here, this 6-month average is much simpler to use. This is computing a 6-month average. So it's ordering by year-month number, going minus 5 relative to 0 relative. So it's a window that goes to -5 from 0. And out of this average, I compute the sales amount. One thing that I always do, and I suggest you to do that because it helps a lot, is to pre-compute the source table. You might notice that even though I use order by, and I know that by default the source table would be all selected of the year-month number, I never do that. I always create the source table by hand, because I want to see in my code what the source table is. It is incredibly easy to make mistakes when you write code with window functions if you don't see the source table exactly in front of you. Anyway, this average X computes the moving average over the last 6 months, and if you want the moving average over the last, for example, 60 days, you just use -60. And instead of sorting by year-month number, here you should sort by date. But of course, doing that requires also to all the changes here, date here, and the same here. And I made some mistake somewhere. Oh, because I don't have the date here, so that doesn't work. Anyway, moving averages and window are quite common and quite simple to use. If you want to compute something like a running total, for example, again, a running total is very close to a moving window, with the noticeable difference that I use this time absolute references. A running total doesn't start from -50 relative, it starts from 1 absolute. 1 absolute is the first element, 0 relative is the current element. So if I create a window that goes from the first ever element up to the current one, sorting by year month, and compute the sales amount, this is going to compute a running total of the sales amount. It is worth noting that expressing the code this way, let's spend a few seconds talking about performance. I'm grouping by year month, I'm computing the sales amount, and I have this running total that creates a window over the month number. You could compute this very same calculation using a regular function, but you would end up building a filter that requires scanning the sales table. Whereas in this scenario, the engine pre-computes a table that contains already the year month number and the sales amount, so it already pre-aggregates values of building the source table, and then the moving window only takes a few elements out of the source table. So performance-wise, it's going to be much faster because it does not require multiple scan of the fact table. Again, is it the preferred way to build a running total? It depends. It depends on how your code is. I'm not suggesting you to go on your code and start changing everything in order to make to use window function rather than using regular DAX code. But spending some time learning how they work might be useful. The last set of DAX function, window function that are worth looking at are rank and row number. They are basically the same function, because they produce a ranking, and they are different than the rankx function, and they are slightly different in the way they compute values. How many of you use and know the rankx function? Some of you. How many of you love the rankx function? One. I don't believe you. That's just not possible. Rankx is one of the worst functions ever. Rankx is, I mean, it does its job, that's not a big deal, but it's really complicated. Computing a ranking with rankx is always painful. Rank, on the other hand, is much easier, because you say, I want to rank. You specify whether you want a dense or sparse ranking. We're going to see in the next slide what the difference is. You produce the source table, and then you provide the order by. All selected product brand returns all the brands. Order by rounded sales. Rounded sales contains the source, the value rounded. Let me see, I should have the code here in DAX Studio. Okay. I created a measure, rounded sales, that does the rounded at the first 10,000. Or 1 million, I don't remember. And then I created two calculations. One is rank dense, the other one is rank skip. So the only difference is dense here and skip here. And the other one is row number. The difference between rank dense, and row number is basically in the way they compute the ranking. Let's take a look at the result. We have the brand, we have the rounded sales, so we have duplicates. Prosware, Fabricam, they are duplicates. Rank dense computes 1, 2, 3, 4, 5, 5. 5 is duplicated multiple times because there are no ways to distinguish between Prosware and Fabricam. So the ranking assigns the same number to both, and because I said I want the rank dense, it goes on with 6. So after 2, 5, we have 6, 7, 8, 9. Rank skip is slightly different. It produces the same result, 5, 5, but then it goes to 7. Because it says, I counted 5 twice, so I skip some values, 6 does not exist, and I produce 7 again. Not to say that people love rank with skip. Whenever I have to do a rank dense is definitely the best option. Even though people don't like neither rank dense nor rank skip. They always want something like the row number. But the thing is, row number ranks in a different way these two rows, which are ranked 5 in dense. They are ranked 5 in 6. They are 6 and 5 using row number. What does row number do? Row number uses the same algorithm of other window function to guarantee uniqueness and then ranks in a unique way. So it says because the rounded sales alone is not enough to guarantee uniqueness, I add the brand. And once I add the brand, I obtain the capability of producing 5, 6, 7. By looking at the number, it probably uses the brand name ascending, so it ranked Fabricam because before or Prosware. Which one to use depends on you. Row number is likely to be the easiest way to produce a ranking. The only thing that you need to make sure that the row number can be computed, so the ranking will be unique. If that is not possible, row number produces an error, and that might be a serious issue. So the difference is only in how they handle ties. If there are no ties, then skip and row number, they all produce the very same result. So in a regular calculation where you have sales amount, it's unlikely you will have multiple customers or multiple salesperson having the same value. But row number is likely to be the easiest function to use. You can obtain again the same result with RankX. RankX is unnecessarily more complicated. So I honestly don't think that RankX makes any sense to use as of today, just because we have rank that works way better. A couple of words about best practices. The first one I already told you, pre-compute the source table. Always pre-compute the source table, because pre-computing the source table gives you a very clear picture of what result you obtain. So look at this code. I'm creating a source table that contains the date month. I'm computing the amount that is the sales amount, and then I want to rank the month based on the sales amount. So I want to see here the ranking of the month based on the sales amount, to see what was the first month, the second month, the third month in the year. What were the best years in the month? Can you picture why this code is wrong? Why it produces the wrong number? We don't have a lot of time. Because the month is not enough. No, the month is actually January, February, March, April. So month is actually the month name. And I'm ordering by amount. Amount is computing the sales amount. But you haven't written enough complicated DAX code in your life. You know what happens when you have the sort by column in the table? You probably should, I mean, it's intuitive, but January, February, March is the natural sort order of months, but it is not the alphabetical sort order. So in order to obtain this result, you sort the month by month number. Make sense? Now, if you use or select the date month is January, February, March, but it does not contain the month number. So it will not compute the correct value, because the query that when this code is actually executed, you have in the filter context the year, the month name, and the month number. The month number is there hidden because it is in the sort by column. I have, only 2 slides, so we can take a look at this, the RankX wrong. Let's get rid of the correct one. You see, it always shows 2, and if you look at the query that is being executed, even though you have year and month here, when you look at the query using Optimize, you enable Performance Analyzer, start recording, refresh the visual. Let's get this query. We don't need that anymore. In the query that is being generated, you see that it's grouping by year, month, and month number. And the month number is needed because the engine will need to sort everything by month number. So if you use the ranking, if you use this ranking that only uses the month, you will not see the result. And you can, even though it's not intuitive, but after a while you develop DAX code, you get used to these kind of errors. If you build the source table and you can see it, you can also create the source table the correct way by using all selected date, month, and month number. You know that you need the month number, you see them in your code, and if you use the correct value, the month correct, you see that shows that this is the worst, this is the best, because this is the best. I actually use ascending rather than descending, so one is the worst, but you get the feeling. This is the first, this is the second, this is the ninth, and rank month good works, rank month wrong doesn't work, but in order to move from from wrong to good, you need to see exactly how the source table is, that it contains the month, it contains the month number, and then you get an idea about where the problem is and you can fix it. If you forget to create, if you just don't get used to always create the source table and see the source table in front of your eyes, then debugging this code turns out to be a nightmare. Yep.
We have a question.
Do we miss a column? No. Why? Yeah, I don't know. This is just all selected date month that returns from January to December. We still have the year in the filter context. No, to be honest, I didn't understand what the question was about.
Yeah, I think the question is, do we need to use this sorting, some kind of sorting in all selected to make it work properly?
No, because all selected here, it just produces the table. Then the sorting happens here when you do the order by amount. That is actually performing the sort order. What we need is that it's not enough to have the month. We need to have the month and the month number. We need both columns because otherwise, when we compute the sales amount, the month number is still in the filter context and it will not produce the correct result. Okay. Last slide, and we have just 1 minute, so incredibly precise for an Italian. So let's wrap up window functions. Window functions are quite intuitive to use, so they are not complicated, even though the concept of current row can be really cloudy. I remember when I started using window function, I always had the feeling that they work like magic. So the numbers were correct, but I had no idea why and how the engine found those functions. That is what started my journey in understanding all the details of applied semantics. I tried to explain applied semantics. I'm pretty sure that it was not entirely clear, but we have articles and we have stuff that you can go read and go deeper if you want. You don't really need to. So I'm not saying that you need to learn applied semantics. You need to learn them only if you really want to understand how complex calculation happens. Otherwise, for regular queries, window functions just work in a regular way. They work with the evaluation context. These are the only functions that search for the current row, both in the row context and in the filter context. So this can be the source of some confusion, even though it's not that complicated. The best practice are always the same with DAX. We have this additional rule, pre-compute the source table in a variable. Do that whenever you use a window function because that helps a lot also in debugging. And this is just a rule for anything related to DAX. Keep it as simple as possible. As soon as you write a piece of DAX code and you say, oh, this is really clever, it's time to stop, rewrite it in a more stupid way because somebody will look at that code after you and will hate you just because you are clever. It's better to write stupid code because then you always know that you also know that it's gonna work the right way. I used all my time, so I don't know. Are there any sessions after that, or is it just lunch? There's a lunch. So if you have questions, you can skip lunch and we talk about DAX. Otherwise, thank you for attending. I hope you liked it, and we'll see you around.